Mr. Ye. Today I'd like to go over how to add and subtract rational expressions. So this is our example of simple rational expression. I'm gonna make a second video about a little bit more harder one. This is a very easy one that you have some type of different denominator, but I'm gonna ask you to adding and subtracting together. Every example has its own uniqueness, so let's pay attention to what happened with the first one. The first one here is 2 over x squared y plus 5 over 3x cubed y. And for me, I will figure out what's LCD here. And LCD in this case, I'm comparing a couple of things. I'm comparing this on the side. I'm comparing the denominator, which is x squared y, as opposed to 3x cubed y. So if I do the comparison, I pick the higher power of each variables or constant. So in this case, the y, this is to the first power, so I'm gonna pick the y to the first power. And then x to the third and x squared, so in this case, I'm gonna pick x to the third. And 3 and 1, so I'm gonna pick 3. So I know my LCD is gonna be 3x to the third y. So the whole idea is to go to make both of them 3x squared y. In this case, this is a lot easier because this one is already 3x cubed y. Sorry, 3x cubed y. So this one already in LCD. This one just need to multiply by 3x. So what I'm going to do is I'm going to take this function and multiply this by 3x, and then this by 3x. So top and bottom. Now in this case, I'm going to have a 3x to the third y. And then all we gotta do is multiply this together, which is 6x plus 5. And you don't have to do any more because this is set denominator. If it's same, then I just add a top. So which is 6x plus 5. And then you're done. Remember, you cannot cancel this x and x because that's technically not legal to do that. You kill a puppy when I say it. So this is not a, you cannot go any further. This is the best you can do. This is another simple case, which is 3 over x plus 2. Well, in this case, this one's x plus 2, this one's x minus 2. Those are the easiest one of rational expression. Student need to get it right away. Now they have to understand x plus 2, x minus 2 are completely different. So in order to find LCD in this case, it's going to be LCD is equal to x plus 2 and x minus 2. So what I need is on this side I need the x minus 2, and on this side I need x minus 2, on this side I need x plus 2, and the x plus 2. Okay, so now on this side I will have x minus 2 times x plus 2. I'm going to have 3 times x minus 2. And now I'm going to have minus 2x times x plus 2 over x minus 2 times x plus 2. Now they have a same denominator, that means I can put it into 1. So I'm going to put all the one bottom is x minus 2 times x minus 2. And on top is going to be 3x minus 6. Now here's the thing. Now this is actually a negative sign, so I kind of like think about this as distributed to 2 terms. A lot of people just distribute the negative 2x times x to 2x squared and say minus sign on the first one. But it turns out this is the second one. The second distribution is where all the mistake happened. Whatever my mistake is here, then you have minus 2x to the square. But instead of minus 4x, they have positive 4x. If I have positive 4x, that's wrong because this negative 2x is going to distribute to 2 as well. So this sign is going to include it, distribute to this negative sign is including 2x, and this 2 things are going to distribute to here. So therefore, it's going to be negative 4x. And then you just combine like term, write in descending order. So this one is first, so it'll be minus 2x squared, and then minus x, and then minus 6 over x minus 2 times x plus 2. Okay, so that's the final answer. The final answer just like this. Can I simplify anymore? Sometimes you can factor this. In this case, I don't think you can, but sometimes you can factor the top and maybe be able to simplify it. Now this is one of the special cases. This is usually covered, not too happen often, but still don't know what to do with it. The least common denominator in this case is actually not x plus 1, x minus 1 times 1 minus x. There's an easier way to approach this question. To make them they are the same, this one's x minus 1, this 1 minus x, so you can just switch the order. How do I switch the order? I can just think about this. So I'm going to say 2x minus 6, I'm going to keep it exactly the same, x minus 1. And like this, I'm going to have a 4 on the top and over like this. What happens is I'm going to take out a negative sign on the bottom, so it's going to be negative parenthesis of x minus 1, and this is subtracting. Okay, so now people says I don't know what to do with that, but here's another rule that you can think about is you have fraction, let's say a over b is as negative, that's equal to negative a over b, or is b over negative a. What happened is right now we are in this situation. I can adjust to this or I can adjust to this. I'm going to adjust to this, put a negative sign all the way into the front. But in the front here, it's going to be 2 negative signs, so change the whole thing to become positive. So again, I'm going to say that again, because those two are negative, so they was assumed to become positive. So I'm going to take those 2 signs becomes positive. I'm going to get 2x minus 6 over x minus 1 minus plus 4 over x minus 1. So I basically just change this 2 negative sign becomes positive sign. Now I have a same denominator, I can add them together. So it'll be x minus 1 of 2x minus 6 plus 4. That's equal to 2x minus 2 over x minus 1. That's not simplified all the way because there's GCF here. 2 times x minus 1 over x minus 1. Now this one can simplify down to 2. Remember, you cannot simplify here, but you can simplify after you factor out GCF. Okay, so you can practice those 3 questions, and then I'm just going to go over really quickly, but you can practice those 3 questions. Those 3 questions are fairly easy. You just need to find out these common denominator. So I'll give you 30 seconds to pause the video and actually go through those 3 questions. So hopefully now you got all 3 questions done correctly, and then I'm just going to go over it. So I hear the LCD. If I just compare the x, it's going to be x to the 4th power. Y is y to the 1st. 2 and 5 is going to be 10. So I need to make it 10x to the 4th y. So what I need is I need to make this side here is 2, I think, 2 over 2. And on this side, I'm going to multiply this by 5x over 5x. So therefore, it's going to give me 20x plus 10 on the top over 10x to the 4th y. I can take out 10, so it's going to be 2x plus 1 over 10x to the 4th y. 10 cancel out, so it'll be 2x plus 1 over x to the 4th y. And that's the most simplified answer. Same thing, I'm going to multiply this side by the least common denominator, y minus 3, and then y minus 3. And this one's y plus 3, and then y plus 3. And then I'm going to get 4y minus 3 over y plus 3, and a y minus 3. And now here it's going to be minus 2y plus 3 over y minus 3, and a y plus 3. Now here's the problem that people make mistakes again. This negative sign here is distributed 2 terms. Okay, not just 1 term. So now I have the same denominator, so I'm just write as 1. And that's going to be 4y minus 12 minus 2y plus minus 6. See that I make a mistake already? Minus 6. So the problem is people make a mistake this sign. So that's going to be 2y minus 18 over y plus 3 and a y minus 3. And there's nothing you can do anymore. You can take out 2, but nothing going to change. In this case, I'm gonna change the same denominator by looking at the order differently, so it'll be 3x minus 18 over x minus 5. So I'm gonna take out a negative sign here, that's gonna be x minus 5, so it's gonna become positive of x minus 5, that's 3. So it'll be 3x minus 18 plus 3 over x minus 5, that's equal to 3x minus 15 over x minus 5. That means 3 times x minus 5 over x minus 5. So those two will cancel out, that's 3. Okay, so that's the first video about rational expression. I'm gonna make a second one, which is a little bit more complicated. The second one, the only thing is different is we had to deal with factoring the denominator, and we're going from there.